Welcome back. Let's finish up understanding the concept of dividing radical expressions and rationalizing the denominator. I have an expression up here. 3 divided by 2 plus square root of 7. I see 3 operations. I see addition, but I cannot add a whole number to a radical, so that's out. I see the square root, but I can't reduce the square root of 7 because 7 is a prime number. It doesn't have a perfect square in it other than 1. I see division, but I can't divide 3 by a 2 plus square root of 7. So I cannot perform any of these operations I see. The problem is if you write this as the final answer, it's unacceptable in math because you're writing the final answer with a fraction bar, and a fraction means division, and your divisor, your denominator, has to be a positive whole number. 2 plus square root of 7 is not a whole number. Now the 2 is whole, but the square root of 7 is not. The denominator of a fraction must be a whole number as an acceptable answer. I cannot walk into your classroom and say, hey everybody, divide into 2 plus square root of 7 groups. It makes no sense. So what we got to learn to do is rewrite this as an equivalent fraction. Well, we understand that concept from elementary school. Writing equivalent fraction means to do multiplication. So we just have to multiply the numerator and denominator by the same term. That would get this square root of 7 to turn into a whole number. Now the difference today is, if you look in your denominator is a binomial, 2 terms. And the rule is to rationalize a binomial, you multiply by the conjugate. So we've already heard that vocabulary word a long time ago. The conjugate of 2 plus square root of 7 would be 2 minus square root of 7. And if we do it to the denominator, we do it to the numerator. When we multiply a binomial by a conjugate, we are guaranteed this denominator is going to turn into a whole number. Now, we make a lot of errors doing this calculation because we're not thinking about what we've learned. The first thing we're doing is multiplying fractions. Multiplying fractions is no problem. Top times top, bottom times bottom. We want to multiply 3 times a 2 minus square root of 7. We want to multiply a monomial times a binomial. That's distributing. You guys and girls don't think of it as distributing because you don't see the parentheses. So if you want to put the parentheses there, be my guest. 3 times 2 is 6. 3 times a negative square root of 7. That 3 is a whole number. It's on the outside of the symbol. This 7 is inside the symbol. You cannot multiply them together and make 21. The 3 stays on the outside. So 3 times a negative is negative 3 square root 7. Now we're going to multiply the denominators. Well, we know a binomial times a binomial is FOIL. So if I do FOIL out the long way just to show you, F-O-I-L. First would be the eyebrow. 2 times 2 is 4. Outers would be the mouth. 2 times a negative square root of 7 would be negative 2 square root 7. The inside is the nose. Positive square root of 7 times 2 would be positive 2 square root of 7. Last would be the other eyebrow. Positive square root of 7 times negative square root of 7. A positive times a negative is a negative. Square root of 7 times square root of 7 is square root of 49. We have learned when we multiply conjugates, we are guaranteed that the outers and inners would be inverse, additive inverses of each other and will cancel out. A positive 2 square root of 7 minus 2 square root of 7 would make 0. So we've talked about this already. There is a shortcut to multiplying conjugates. You don't perform first, outer, inner, last. You just do the first and the last. So you can do that in your head. 2 times 2 is 4. Positive square root of 7 times negative square root of 7 be negative square root 49. Now I know what you're thinking. You're saying, but Ms. Black, there's still a square root in the denominator. But look what's inside now. It's 49, which happens to be a perfect square. So we can reduce this. This denominator is really going to become 4 minus 7. Do you all see that? The numerator is 6 minus 3 square roots of 7. Well, we can't do anything with a square root of 7. It's a prime number. We're stuck with that. We can't do 6 minus 3 square roots of 7 because this is a whole number and this is a radical, and they're not like terms. So the numerator stays put, but now the denominator is 4 minus 7. Well, what is that, everybody? What is 4 minus 7? Very good. That makes the denominator negative 3. So now we have 6 minus 3 square roots of 7 divided by negative 3. Well, now we're still not done because this brings us back to the beginning where we were talking about polynomials. If we divide a binomial by a monomial, we're saying divide both of these terms by negative 3. And you can. 6 can divide by negative 3. I'm going to write it like that. And negative 3 square roots of 7 can divide by negative 3. Because remember, that's the definition. This division bar goes all the way across. It means take both of these terms in the numerator and divide them by negative 3. So let's do it. 6 divided by negative 3 would be negative 2. Negative 3 square roots of 7 divided by negative 3. Well, a negative over a negative makes a positive. 3 divided by 3 makes 1. And we would get positive square root of 7. And that is your final answer. Negative 2 plus square root of 7. Now I know what you're saying. You're saying there's still a square root symbol. You're right. But is that square root symbol in the denominator of a fraction? Well, there's not even a fraction here anymore. So this is acceptable. The only time you cannot have a radical symbol if it's located in the denominator. And to get it out, we do rationalizing. And now we learned if we have a binomial, the only way to rationalize, multiply by the conjugate. And that finishes up Module 15.